Okay, so today we will start with the hexadecimal representation. In the book, it's after binary arithmetic. We have done the prefixes, binary prefixes, the kilobytes, megabytes, and then 1.13 is hexadecimal number system. Hexadecimal number system is we have just one lesson. So we have done this base 10 numbers and base 2 numbers. Hexadecimal mean hexa, you know, the word hexa itself, what does that mean? 6. So hexa and decimal means 16. So that would be which base? 16 base 16 numbers. Okay. Now, if you look at the table, again, when we are talking about the decimal values or the nonary values, after 9 we go to 10. But the in the hexadecimal value, we okay. In the hexadecimal after 9, we represent it as A. So 10 is represented as A. Is A, 11, B, C, D, E, F. So basically in hexadecimal, we have from 0 to F. And the same in the binary, you know that conversion from decimal to binary. And I told you about how to make the table. The rightmost bit, you make 0, 1, 0, 1. You can see over here. And the next two bits, the next bit, a group of 2, 0, 0 is 1, 1, 0, 0, 1, 1. Then we have four combinations, and then in the last we go to 8. Remember, 1, 2, 4, 8. So 8 digits pair, you can write it in the table, and then on the right side you can write the derivative values. You don't have to convert for every value. So just whenever you have the conversion, especially with the hexadecimal, because you need to, whenever you are converting from hexadecimal to simple decimal, you need the binary conversion for that. So make this table beforehand. Each group, remember the 4 bits, what are they called? 4 bits nibble. Okay. And each group of 4 bits, that is a nibble, it can be represented with just 1 bit of hexadecimal. Now the question comes that we already have binary, we have decimal, so why do we need another number, base number to use in computer sciences? What do you think should be the reason? What would be the reason? Well, one thing, the computer itself is still storing the main storage on the hard drive or the memory is still in ones and zeros. It's never going to be ABC. What is going to be? It's like if you are the computer programmer or the hardware programmer, you cannot write your commands in zeros and ones. No human will be able to understand that. Computer understands zero ones. We understand simple numbers or alphabets. We are representing 10, 11, up to 16, up to 15, using the alphabet so that it can take one. Yes, it can take one space, but remember at the back end, it is still being stored as the binary. The only reason we are using the hexadecimal is it is convenient for the humans. We need to represent it in a way that we can understand, and it takes lesser space or more bits are possible. It is convenient to write numbers and hex compared to a binary system. It is helpful for programmers coding in the low-level languages. Low-level languages are the ones where your circuit programming, all of the programming that is done for the motherboards or for the circuits. Instead of 4 bits, it is enough if they type a single character. So again, remember, it's kind of the interface between the computer and the humans. Have you seen this, this number? Have you seen this on the computer anywhere? Where? Like वो तो उसका code है ना? Whenever there is an error in the memory, there comes. Did you ever get the blue screen? It's called the blue screen of death. I know it doesn't, hold on for more time, and so that you can read through it. But you can search images for it online. You will see that it tells you the exact space, exact place on the memory where the error has occurred. So whenever there is an error in the memory, it always shows the hexadecimal position. The location of the memory dumps, it's always in the hexadecimal. So computer uses that to communicate with the humans with the program. Okay. Now, will you see this number? A is, what is the decimal value of A? 10. And if you see 10, how to convert it in binary? 5, 2s are 4, 1, and then 2, 1, 0. So 1, 0, 1, 0. This is A. 3, 0, 0, 1, 1. F. F is the last number in the range. So you can think of it that all the bits are on or all of it is 1. F, again, 0, 1, 0, 1. That is 1, 2, 4 plus 1 is 5. And then we have 8. And then at the last one. So if you need to convert a decimal number into hexadecimal, you do need to convert that into the binary first, or even the vice versa. If you're converting from hexadecimal to the decimal, you need the binary conversion first. Converting binary to hexadecimal. So we need to split it into group of 4. If there are some extra bits left, you add the leading zeros to make it 4. So we have 4 groups. 0, 0, 1, 0 will be 2, 1, 1, 1, 0. That is 2 plus 4 plus 8, 13, and 13 is 10, 11, 12, 13, A, B, C, D, D. And this one, 12 will be C. And 1, 0, 1, 0, 8, 9, 10 now. 1, 2, 4, 8, 8, and plus 2, 10. So that would be A. 2 है 2E I think we did something wrong over here. DE anyways 2E C 9 8 plus sorry we are making it wrong. The place value is 1248. ये सही तो है. So 8 plus 2 would be 10. This should be 10 over here. Okay, converting hexadecimal to binary. Again, equivalents you have to write in the binary first, and you combine the groups 0 1 0 0 1 1 0 1 0 1 1 1 1. Okay. To convert the denary into the hexadecimal. Now I was trying something that if we divided by 16, I think it is correct. In this case, convert it into binary, we keep dividing by 2, or let's make it 1 2 4 8 16 32 64 and 128. So we have 131 minus 128 would be 3, so 1 1. Okay, all the rest are 0. Make it into the group of 4. So this group becomes 1 2 4 8 8, and this group becomes 3 83. And you can see this way as well. Remember, we did the division by 2 because if whatever base it is, you can keep dividing it to convert it into that specific base. Agar 16 base hai, तो you will keep dividing it with 16. Okay? You will need calculators for this, but I'm just checking. This is 83 or 83. So in this way, you don't need to convert it into the binary. But I suggest that because the book is using this method, they might be asking for this method. Okay, let me check the table. 0011 is कुछ हम गलत कर रहे हैं, I think. 0011 is 3. So why are they writing E? E is 1110. Anyways, the method is the same. You divide the binary number into group of 4, and then you convert them into the hexadecimal numbers. Converting the hexadecimal to decimal on the denary numbers, as it is 16 base, so 16 power 0, 16 power 1, and 16 power 2. When you do the multiplication, 15 plus 160 plus इसका क्या आएगा 16 176 है no 146 146 into 7. Okay, the answer should be 1967. The method is the same with the binary to decimal conversion, only difference is the base. Application of the hexadecimal numbers. You have done HTML when you were in grade 8. Not 8, sorry, 7. Have you done the CSS in that? In which you apply the styles, the colors. Remember the color code, or did you write the names of the colors? You wrote the code. So what was the code? It used to be something like this. A1 or then 3, 2, B2. Did you do something like this? No? So this way, this is RGB, red, green, and blue. Blue code, green code, and then the red code. This representation is also in the hexadecimal. This is the most commonly used and easy to use, you can say convenient. Colors, RGB color model, errors, as I said, the memory dumps or the errors coming in the hardware are represented using the hexadecimal numbers. MAC addresses. MAC addresses are the manufacturing code for any kind of internet device. If you have mobile, any device that can be connected to the internet will have a hardware which detects the signal, internet signals and everything. That hardware has a code. That code is called a MAC address. How to see your computer code? See, the internet is connected. You can go to the properties. Link local IP version v4. This is the IP address. IP address is the location of your computer on the internet or identification. As you can see, we have FE80. C, then we have 2 columns. CC2579A031F6. This is also hexadecimal. And physical address MAC D2-8ECBF7077E. So this is the identification code for any kind of device, hardware, which can connect to the internet, or your mobile will have it. Even if your TV, the smart TVs, they are able to connect to the internet, its hardware device or the wireless device is going to have this MAC address. MAC was a manufacturer. A was something, last one is code. I don't remember it right now, but it is something like this. URL are the website addresses. We will see how they are used. Assembly code and the machine code. As I said, that it's the machine code or the assembly language is the lowermost language that the humans can use to program the hardware, program the computer system. So again, we cannot still write the coding or the commands in binary, so we use the hexadecimal codes. Okay. You can see reds, greens, blues, as I said over here. If we have this code, all zeros meaning no black, no green, and no blue. इसमें भी एक zero ज़्यादा है. Remember the physical law of the light. If there are no colors, there is only, it's the absence of colors, so it's black. All F is the highest number possible, or the highest you can say shade of the color. All of them combined will become white. 0 0 0 0 FF, meaning there is no red, no green, but blue is maximum. So this is the pure blue color. And same way we have red and green. Red and green combined gives the pure yellow. You have seen this window, right? And color model RGB, you can see R, green and blue. Errors, it's something like this, like location of the memory and the contents of memory. Okay, it's just like a seed number and what's sitting on that seed. So the location is also represented in hexadecimal and the contents are also represented in the hexadecimal. The error message contains a hex number that represents the memory location. Information is very beneficial. Again, who is working with the hardware programming, they will be able to understand this. Right now, we don't understand this. Whatever the error is or what's happening, looking at the contents, but there is something happening. The error can be easily rectified by verifying the code in that particular location. This process in which the contents of memory is displayed or stored in a storage drive in case of a system crash is called memory dump. Whenever especially we get a blue screen, it means that there has been some drastic problem with the operating system and it cannot function anymore. So the blue screen comes, and when you restart, I don't think that Windows 10 or 11, they give the error anymore, but Windows 7, they used to, whenever you restart, it used to tell that this was the error and this was the memory dump. So what does the operating system do? It, whatever location the error came, it copies it somewhere for reference. That is called the memory dump. Okay. Compared to binary, this is easier to understand. Now, as you can see, the binary code of DEF6 B2, ये इसमें तो नहीं है वैसे, but anyways, the binary is this, and it's very difficult to represent and even to understand. The programmer must have the knowledge about computer architecture to interpret the result. There are job titles, system engineer or the hardware engineer. This is their job, to understand this and then to get to the error. MAC addresses, as I told you, media access control. Totally wrong about that. A media access control address refers to the number on the internet that uniquely identifies a device on the internet. This is the address of the network interface card. Network interface card, the hardware device, just like, kind of a USB, which enables a computer system or a mobile or laptop or tablet to connect to the internet. It's made up of 48 bits. As you can see, either it is in dash or it's represented using colons. The first half of the address represents the identification number of the manufacturer, and the second half represents the serial number of the device. Serial number of device, and this part is for the manufacturer. With the same code. 0014Q234 refers to a device made by Dell with a serial number of 34AC4F. There are two types of MAC addresses. Now, even just right now, there was a point coming in my mind. If you think about the combinations, how many, like there are like finite, not infinite, but there are finite number of combinations that are possible if you have 6 places to use from 0 to 50 or 0 to F. What if, of course, there are like the billions, trillions of devices, old devices, new devices, they are manufactured every day. So I don't think that this will be enough, right? So two types are used: universal administrator MAC, which is UAA, and locally administrator MAC address. It's UAA, universally administrator, is set by the manufacturer and is most commonly used. This address is not changed most of the time. So this is kind of the universal recognition of the manufacturer. In the case of UAA of the devices chain, it is crucial to make sure that the UAA is unique. Every manufacturer should have a different unique number so that it can be identified. I don't think that this is in your syllabus. Let me check in your book. Okay, memory dumps. You can see this is a huge memory dump. Yeah, that's it. You don't need to know about this in detail, because these slides are basically used for all A levels at Excel and AC. Okay, URL. Again, ASCII codes are used to represent the web addresses. Sometimes you will see, try to, look at the web addresses whenever you're opening internet now. Many of them will have %20. %20 is the representation for space, for the space bar. Each digit, or sorry, each alphabet is represented by a hexadecimal number after a percentage sign. Percentage donates the hexadecimal values are used. They are used to represent addresses of files and web pages to improve security. A user is protected from accessing a fake website when he's asked to use a hexadecimal URL rather than a URL with letters that could be misleading. Why would they be misleading? A fake website can be something like this that we might not notice if you are typing GOOGLE. If there is a virus on your computer, what does that virus? That virus can redirect you to a fake website, which address would be GOOG. And it's a very, very little minute difference, which we might not be able to see. Many fake websites, what they do, especially with the bank websites, PayPal had this. Whenever they are asking for the logins where credit cards are being used, so that information can be fetched using the fake website. So that is why, to increase the security, if the website can ask you to write the address in the hexadecimal. Assembly code and machine code. Again, we have this full chapter later on. An assembly code instruction will just give you an example. ADD, which is add, actually is translated to machine code as 0100, which is equivalent to 4 in hexadecimal. Now it is enough for the programmer to type a single digit 4 when compared to the 4 digits 0100. When we do the assembly code in detail, we will see how the instructions are written. You just, for now, you just need to know what are the applications of this hexadecimal. Okay, we have done the colors, hash sign color. This is how it is used in the HTML. How much time? The lesson is still 8:40, right? Now, quickly, can you convert the derivative number 248 to hexadecimal? Do you want me to open the table? 248. Bell. Okay, for the homework, you have the activities. It's written over here. 1F and 1E. Okay, go through the examples. They explain it very clearly. 1D में क्या है? Addition and subtraction. Yes, do it. We have done that. ठीक है? Algorithms. On Thursday, we're going to have that. Okay. The timetable? Okay. Yes, okay.